Hello again, this is Mr. V. Hill, and today we're going to talk a little bit about slope. This should mostly be review for y'all, but the big idea here is that since we're getting into a unit on linear functions, we need to know what a linear function actually is. And, well, basically the whole idea is it's linear because it makes a straight line. Okay, well, what do we mean by straight? Well, not curved. Okay, well, what do we mean by curved? And so it gets a little bit goofy when we're just talking about that kind of idea. So we need a more precise definition, and specifically a linear function is a function which has a constant rate of change or slope. These two things are interchangeable. Rate of change is the same thing as slope. And so, well, we need to define what slope is then. And so rate of change or slope is defined to be the change in y, or the dependent variable, divided by a corresponding change in x, or the independent variable. Sometimes we use this notation here with a little triangle, which is actually the Greek letter delta, and delta usually refers to change. So slope is the change in the y divided by the corresponding change in the x. And sometimes we use these two words called the rise and the run. When you're looking at a graph usually, rise meaning we're going from one point to another point, how far do you have to move up or down, divided by the run, how far you have to move left or right. And also we have a formula for slope, which is given by this little thing with the subscripts, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now what these little subscripts are referring to, well, this x sub 1 means the x coordinate of the first point, x subscript 2 is the x coordinate of the second point. Up here, y sub 1 is the y coordinate of the first point, y sub 2 is the y coordinate of the second point. So it's just the difference in y coordinates divided by the corresponding difference in the x coordinates. Notice we're going from the second point to the first, second point to the first. You could switch these around and it's the same thing. Doesn't really matter. But let's just look at an example here. So if we want to find the slope of the line that passes through these 2 points, -3, 2, and 5, -4. And any 2 points are going to determine a unique line, so you only need 2 points to find the slope of a line. And I drew a little sketch down here of that. Here's the point -3, 2, and over here is the point 5, -4. Okay, so if we're just looking at the graph, looking at sort of the rise over the run, all you have to do is just kind of, if we have nice points anyways, just kind of count. We'll see how far do you have to move vertically and divide that by how far you have to move horizontally. Now if you're moving down vertically, that's going to be a negative rise. So we're dropping down, let's see here, 1, 2, 3, 4, 5, 6. So this rise would be -6. And then after we go down 6, we need to move to the right. Let's see here, 1, 2, 3, 4, 5, 6, 7, 8. So there would be our run of 8. So here's the rise, -6, here's the run, 8. So the slope, just looking at the graph, is going to be equal to -6 over 8. And of course we would want to simplify that down, since these have a common factor of 2, that's equal to -3/4. Pretty simple. Or, if we want to use the little formula, well, here's the first point, and here's the second point. I always advise writing in right next to it that this guy is x sub 1, y sub 1. Meaning the x coordinate of the first point is there, the y coordinate of the first point is there. This is x sub 2, y sub 2. X coordinate of the second point, y coordinate of the second point. No problem. So now we just put that into our slope formula, which was y2 minus y1 over x sub 2 minus x sub 1, or y2 was -4 minus y sub 1 is 2, x sub 2 is 5 minus x sub 1 is -3. And we do the arithmetic here. -4 minus 2 is, of course, -6. 5 minus a negative 3, that's actually plus positive 3, so that would be 8. And again, we get the same thing. Simplify that down to negative 3 over 4. And there's the slope between these 2 points. No problem. Next thing. Another example. Suppose you want to determine if this table that we're given right here represents a linear function. Well, again, linear means you have a constant rate of change or a constant slope. So we're given 4 points here. We just have to figure out the slope in between each of these pairs of points. And if it's always the same, then yes, it's linear. So the first pair, the slope is going to be, well, the y-coordinate of the second point minus the y-coordinate of the first point, negative 5 minus a negative 3, divided by the corresponding x-coordinates. X-coordinate of the second point is 0, minus the x-coordinate of the first point would be negative 4. And we can simplify that down a little bit. Negative 5 minus a negative 3 would be adding a positive 3. That's going to be negative 2. 0 minus a negative 4 is going to be 4. So that's just negative 1/2. So that's for this first pair of points. The second pair, we'll calculate the slope between those. The y-coordinate of the second point is negative 8 minus the y-coordinate of the first point, which is negative 5, over the corresponding change in the x's, which is going to be 6 minus 0. X-coordinate of the second point minus the x-coordinate of the first point. Negative 8 minus a negative 5 is going to be negative 3. 6 minus 0 is 6. And again, that's negative 1/2. Great, we found the same slope. So it's linear, right? Oh, hold on. We've got one last pair that we need to check. So the third pair of points, again, the slope is going to be the y-coordinate of the second point, negative 13 minus the y-coordinate of the first point, negative 8, over the x-coordinate of the second point, which is 16, minus the x-coordinate of the first point, which is 6. We'll do the arithmetic there. Negative 13 minus a negative 8 is going to be a negative 5. 16 minus 6 is, of course, 10. And we simplify that down, and again we get negative 1/2. So, since the slopes were always the same, this thing over here definitely represents a linear function. And so with that, I'm going to leave you with a couple of practice problems. Work through these right now while everything is still fresh in your mind, and maybe we'll see these again in class. So, work these through right now. Seriously, go do it. No, don't go check your email. Do these problems right now. Do them. Seriously. Do them. See you in class.